Okay, so let's start reviewing for the final exam. So if you recall, the 6 topics of the free response questions that will be on the exam are posted in the Canvas announcement. So remember, there's 12 multiple choice questions, which is a fair game, anything from the semester, and then 6 free response questions, and I'm telling you what those topics are. They are all 6 of those questions, or topics, I should say, are listed in that Canvas announcement. Within this review, I have provided 2 examples of each topic, okay? So, first, we're going to be working with single population proportion hypotheses test. This was like from the very first chapter. This is back in chapter 6, I believe, 6-4 and 6-5. There was a small introduction to it in 6-3 as well, but really the main focus was in 6-4. So, pediatricians at a research hospital are considering a new brand of cough syrup for children. The current brand they use lessens coughs in 80% of children they administer it to within 20 minutes. They're going to test the new brand to see if that proportion will increase. The pediatricians gathered a random sample of 100 children and gave each of them the new cough syrup. They found that 88 from the sample had their coughs lessened after 20 minutes. In the following steps, you will test the following claim. So here's the claim. At a 5% level of significance, the population proportion of children who take the new cough syrup had their coughs lessened after 20 minutes is more than 80%. Okay? So, part A. State the null hypothesis, the alternative hypothesis, and what type of test this is. So, starting with the null. Remember, the null is essentially your baseline. It's what we're starting with. So the population proportion equals, well, we were told previously that the current brand lessens the coughs in 80% of children, right? That's our starting point, 80%. So P equals 0.80. That's what we start with. The alternative hypothesis is P is, remember, you have 3 choices. P is greater than, P is less than, or P does not equal the proportion that was previously stated. And in this case, as we see right here, we want to test at a 5% level significance if the population proportion is now more than 80%. If it is now more than 80%. So what is that? Is that less than, greater than, or does not equals? Greater than. Oops, I just erased it. So greater than 80%. Is this a left-tailed, right-tailed, or two-tailed test? Right-tailed, because it's a greater than problem. Greater than alternative hypothesis. Any questions so far? Okay, part B. Calculate the sample proportion P hat, round to 3 decimal places if necessary. So P hat equals, and you get your information to calculate P hat from the problem itself. So it says right here, pediatricians gathered a random sample of 100 children, gave each of them the new cough syrup. They found that 88 of them had their coughs lessened after 20 minutes. That's your sample. Out of the 100, 80 of them met the criteria, or 88 of them met the criteria that we're looking for. So that's 88 out of 100 from our sample. In decimal form, that is 0.88. Part C, calculate the standard error for this one population hypothesis test. The standard error formula is on your formula sheet, the very first formula sheet, okay? It's on the front page. Remember, the front page was Unit 6. The back page was Unit 7. And then the front page was first confidence intervals and then hypothesis testing. We're working with hypothesis testing, so that's what we're working with. So look for the standard error for hypothesis testing from your first formula sheet. And you will see the following. It says standard, I'm abbreviating, standard error equals, and if you wanted to, you could denote it with this notation. But overall, it equals the square root of P times 1 minus P all over N. Okay? That's the formula. It's just to calculate the standard error. You do the square root of P times 1 minus P all over N. Be careful. This is probably the most common mistake I saw students make on the exam. What is our P? What's our P value?
The population.
0.80. Yeah, it's 0.80. You said P up here, right? The mistake I saw students make is they were plugging in 0.88, but 0.88 isn't P, that's P hat. Big difference, right? P hat is the sample. That's not what it's asking for. It's asking for P, which you stated originally up here from the null hypothesis. So that'll be 0.80 times 1 minus 0.80 all over N. Remind me, what is N? The sample size. Good, the sample size. And what was our sample size in this problem? 100. From there, it's calculator. Okay, calculator. And you should get exactly 0.04. Any questions there?
P was the population.
P is the population proportion, which is based on what you stated for your null hypothesis.
Okay, so it's always our null hypothesis?
Yes, for P.
Got it.
Yeah. Any other questions? Okay, part D. Calculate the z-test statistic for this one population hypothesis test. I am still referencing the formula sheet. I'm still on the front side of that formula sheet under hypothesis testing. Actually, right below where it says standard error, we have the z-score. And we have the formula z equals p hat minus p all over the standard error. And we now have all three pieces of information. We can plug them in. P hat, we found previously to be 0.88 minus P. We said originally in the null hypothesis was 0.80 all over the standard error. We just found the standard error in the previous step. That was 0.04. Once again, calculator, that will give you 2. Questions?
Will there ever be a fraction?
You could get an ugly decimal, in which case round to, it'll probably say like 2 or 3 decimal places.
How do you, I can't remember, how do you turn a decimal, a fraction into a decimal again? You divide the bottom.
You could just divide, yeah, just take the top number, hit the division sign, and then divide by the bottom.
Okay, cool, thank you.
Any other questions? Okay. Part E. Find the p-value for your z-test statistic from part D using your calculator. Show your work and write down what you entered in your calculator to find the p-value. Round to 3 decimal places. All right, so recall to find the p-value for scenarios such as this. Excuse me. You would do second distribution, right? Second distribution in your calculators. And then scroll down to the second one down to normal CDF. And then if you recall, you do your lower bound, then your upper bound. In this case, our lower bound is 2, which is our test statistic. The upper bound is infinity, or 9999999. because we said it was a right-tailed test, so it was going to the right forever towards positive infinity. Always followed by mean and standard error of 0 and 1. Always followed by 0 and 1. What if this was a left-tailed test? How would it differ? Yeah, it'd be good. It'd start with negative 99999 because it'd be going towards negative infinity first. Good. Plugging that into your calculators, you should get 0.023. I might have rounded there. Yes?
Even if it's left-tailed and you do -9, and the other number, the z-score, is positive, it still will be that way?
Yes.
Okay.
Yeah. That's more rare to occur. Typically, if it's a left-tailed test, we expect our test statistic to be negative as well. That's not an always though. But yeah, if it's a left-tailed test, start with the negative 99999, negative infinity. If it's a right-tailed test, then your second value will be the positive 9999 or positive infinity.
And you said 0 and 1 are the mean and...
Standard deviation. Yeah. Okay. Good questions, guys. Any other questions? Okay. Part F. Based on the p-value you found in Part E, at a 5% level of significance, do we reject or fail to reject, or not reject, right, the null hypothesis? Does the data support or not support the alternative? Answer both questions and give an explanation for the conclusions you make. So, remember, to make those determinations, we always take our p-value, rewrite it in percent form, so it's 2.3%. Compare it to your level of significance. 2.3% is less than or equal to our level of significance of 5%. So that makes it statistically significant or not statistically significant? Statistically significant.
Would we be wrong if we don't say less than or equal to? Because I usually write it out and I'm going so fast that I just say that our p-value is 2.3%, which is less than our 5% level of significance.
I would be okay with that.
Okay.
So statistically significant. So therefore, do we reject or not reject the null? Reject the null. Good. Reject the null. And do we support or not support the alternative?
Support.
Support the alternative. Good. It's coming back to y'all.
Yes.
Kind of familiar? A little bit? Okay. Last part G. Now state a final conclusion in context. At 5% level significance is the population proportion of children who take the new cough syrup and have a cough lessened after 20 minutes more than 80%. Okay, so at the 5% significance level, the sample data support the claim, right? We're supporting the alternative hypothesis, so we are supporting the claim. Support the claim that the population proportion of children who take the new cough syrup and have lessened coughs is more than 80%. Right? Our alternative hypothesis, if you recall, look back here, our alternative hypothesis was that it's more than 80%, and that's what we are supporting. Any questions there? I'll leave it here for a second, and then we're going to continue on.
like a lot of them are 2 examples, like one from the exam, one from the review. That doesn't necessarily mean that there's gonna be 1, 2, 3, 4 free response questions on this.
There's 6 on them.
6 total.
There's 6
So it
total.
could be any of these examples.
There will be, well, they're not going to be they're not going to be copy word for word,
Yeah, I
that
know.
example, but there will be one of each topic, one of each category.
And then categories, you mean single population, 2 population.
Exactly. Yeah.
Just like a refresher for the p-value, it's always gonna be the last digits, the 0,1.
In this case, you'll see later on we did ones in which case it was not
Subtract
it was like degrees of freedom or something like that, yeah. Yeah. But for this one, when it's a single population proportion hypothesis test in which we are using the normal CDF, then yes. Good questions, guys. Any other questions? All right, I'm going to continue. Number 2. In 2008, 25% of pet owners believed that vets charge an unreasonable amount for their services. In 2015, a survey conducted by Gallup reported that 400 pet owners believe vets charge an unreasonable amount for their services from a random sample of 5,000 pet owners. In the following steps, test the following claim. At a 5% level of significance, the population proportion of pet owners in 2015 who believe vets, charge an unreasonable amount for their services is less than 25%. Round all parts to 3 decimals where needed. So part A, state the null, alternative, and what type of test this is. So the null hypothesis is that P equals what? 0.25, good. All right, that's our baseline. That's what we're starting off with. That's our assumption. The alternative is P is what? Less than, greater than, or not equal to? Less than. And less than what?
0.25.
0.25. Good. And it even says so right here. Less than 25%. So is this left-tailed, right-tailed, or two-tailed? Left-tailed. All right. Next, let's calculate the sample proportion. So remember, that's always represented by p hat. So p hat equals, and let's see, where's our sample? Well, from our sample, it says 400 pet owners believe the vets charge unreasonable amount out of a sample of 5,000. So that's how we set up our fraction, 400 out of 5,000, which that should give you 0.08. Next, we can calculate the standard error. Again, I'm still working off the very first formula sheet. Under hypothesis testing, we are given that the standard error is equal to the square root of P times 1 minus P all over N, where P we stated in our null hypothesis is 0.25. So that's 0.25 times 1 minus 0.25 all over N. N is our sample size. What's our sample size this time?
5,000.
5,000. Using your calculators, that should reduce to, and we're going to round, 0.006. Next, let's calculate the z-test statistic. And again, formula on your formula sheet. Z equals p hat minus p all over the standard error. P hat we calculated previously to be 0.08 minus p, that's what you stated originally in the null, 0.25. All over the standard error. We just found the standard error in the previous step, so divided by 0.006. Plug that into your calculators, and I'll give you negative 28.333. Next page, find the p-value. So p-value equals, and actually, I forgot that the p-value is actually, that's listed on your formula sheet as well, right underneath the z-score. So on the first formula sheet, under hypothesis testing, we did standard error, then we did z-score, and then if you look just below that, it says p-value. And it's telling you, it's reminding you what function to use in your calculator. It's reminding you to use the normal CDF. All right, what's my lower value?
Negative 99999.
Negative 99999 because it's a left-tailed test. Then the z-score was negative 28.333, followed by 0 and 1. Plugging that into your calculators, that will give you 0. Next, we're going to state what to do with the null and alternative hypotheses. Well, our p-value is 0%, which is less than or equal to our level of significance of 5%. So is this statistically significant or not statistically significant?
Statistically significant.
Good. Statistically significant. Do we reject or not reject the null?
Reject.
Reject the null.
Support.
And support alternative. Lastly, part G, state a conclusion in the context of the problem. At a 5% level of significance, the sample data support the claim that the population proportion of pet owners in 2015 who believe vets charge an unreasonable amount is less than 25%. Any questions? All right, let's keep going. All right, we are, so there will be one free response question similar to these type of problems. One free response question from that topic that we just did, okay? So next, we're changing topics. We're now doing 2 population proportion confidence intervals. There will be one problem on the final exam free response that's like this, and I have 2 examples to work through with you. So, number 3.
Oh, I have a question.
Yeah.
So, there for sure won't be any confidence intervals for single populations?
No.
Good to know.
Okay, so a well-known study of 22,000 male physicians was conducted to determine if taking aspirin daily reduces the chances of a heart attack. Half of the physicians were given a regular dose of aspirin, while the other half was given placebos. 6 years later, among those who took aspirin, 104 of them had suffered heart attacks, while those who took placebos, 189 had suffered heart attacks. Now consider constructing a 99% confidence interval to estimate the difference in population proportions. Round all parts to 3 decimals if needed. Part A, find the sample proportions and sample difference. Okay, so we're going to have 2 different sample proportions, right? Because one group took aspirin and the other group took the placebo. So I'm going to call the first group aspirin. I'm going to call that my P sub 1 hat. Okay? P sub 1 hat. So how many of people who took aspirin had heart attacks? Where'd that go? 104, right? Among those who took aspirin, 104 had heart attacks. 104 out of how many? What was the sample size?
22,000.
Yeah, careful. There was 22,000 total, but half of them took aspirin and the other half had placebos. So you got to split it in half. So 11,000. Okay. So the first sample proportion for aspirin will be 0.009. All right, now for the second group, the placebo group. So that's my P sub 2 hat. Those who took the placebo, how many had a heart attack?
89.
189. So 189 out of, again, 11,000, because they were split evenly. That will give you 0.017. And then lastly, find the sample difference. What does difference mean? Subtract. So it's just telling you to subtract these 2 values. That's all that means. Okay? So P1 hat minus P2 hat, that's 0.009 minus 0.017, which is negative 0.008. Any questions there?
I have a question.
Yeah.
Oh, never mind. It says it.
Okay, so part B. Find the estimated standard error. This formula is on your formula sheet. Still the formula sheet from exam 1, but now go on the back side of it where it says unit 7. Okay, unit 7, confidence intervals, because that's what we're solving for, right? Confidence intervals. And if you look there, it says what the standard error is. So we are told that the standard error is the square root of P1 hat times 1 minus P1 hat all over n sub 1 plus P2 hat times 1 minus P2 hat all over n sub 2. So plug in. We have all the information we need, and we just plug it in. P1 hat, we said was 0.009. So 0.009 times 1 minus 0.009 all over n sub 1. The sample size we said was 11,000. Plus then P sub 2 hat times 1 minus P sub 2 hat which we also know P sub 2 hat is 0.017. So 0.017 times 1 minus 0.017 all over the sample size for the placebo group, which was also 11,000. Are they always going to have the same sample size?
No.
No, it just so happened that in this problem they did. That's calculator, taking your time with your calculator, okay? So to conserve time, practice with your calculator, and if you're struggling with it, come ask me, okay? But you should all get rounding to 3 decimal places, 0.002. Okay. Next, finding the margin of error, which is also on the formula sheet. Still on the formula sheet. Unit 7, under the confidence intervals, it says margin of error E equals Z sub C times the estimated standard error. Which remind me, how did we find that Z sub C?
On that chart.
It's on the charts, right? Look to your formula sheet. Look to your formula sheet, the critical values table, right? Remember that? That's how we find our Z sub C. So what you need to do is identify the confidence level. What was our confidence level? 99. Look to that on the formula sheet, and it tells you what your Z sub C is. It is 2.576. Times the estimated standard error we just found in the previous step is 0.002. Multiplying that together, rounding to 3 decimals, is 0.005. Any questions so far? Okay, part D. Write the 99% confidence interval in interval notation, which is also given to you on the formula sheet in case you blank on it, okay? Recall that it is P1 hat minus P2 hat minus E, comma, P1 hat minus P2 hat plus E. And then it's a matter of substituting in. We know this P1 hat minus P2 hat, we already solved for that here, right? We already solved for that there. We had gotten that to be negative 0.008, right? We already found that. So then we're just going to subtract E and add E to that value. So negative 0.008 minus E, which was 0.005, comma, negative 0.008 plus E, so plus 0.005. Simplifying each of those, negative 0.008 minus 0.005 is negative 0.013, comma, negative 0.008 plus 0.005 is negative 0.003. And if it's asking for it in interval notation, it needs to be in that interval notation. Don't forget the comma. Don't forget the parentheses.
Where did we get the 2.576 again?
From here.
Oh, okay. Okay. Thank you.
Part E, explain what the confidence interval means in the context of the problem. Well, we are 99% confident. Okay, we are 99% confident that the difference between, right, because that's what we're doing. We're we calculated the difference between these, right? Overall, we want to know what the difference is between those taking the aspirin or versus taking the placebo. So we are 99% confident that the difference between the proportion of those who had a heart attack while on aspirin and those on the placebo is between negative, and then convert these to percentages, negative 1.3% and negative 0.3%.
Isn't the next part basically us repeating that?
Not exactly, no. Not quite. Similar, but not quite.
It's just starting with researchers can say with 99% confidence that the.
So part F is more of a further, more in-depth interpretation that we're about to do. So what we're saying is that we know the proportions of people who have a heart attack while on aspirin versus those who have a heart attack while taking the placebo. We know that those proportions are going to be different. So when we subtract them, there's going to be some difference between them. Right? And so we're seeing that the difference between those who have a heart attack while on aspirin versus a placebo, I don't know what it's going to be, but the difference between them we're expecting to be within this range. So part F, based on the confidence interval, can we conclude that aspirin will reduce the number of heart attacks in male adults? And if so, why?
Yes, because they're negative.
Yes, because they're negative. So this goes back to when we did the P1 hat minus P2 hat, right? This goes back like to that. P1 hat was what? What did it represent? The aspirin, right? The heart attacks on aspirin. Heart attack on aspirin. P2 represented the heart attack on the placebo, right? And since our confidence interval only had negative results, right? Our confidence interval was only negative results. We're saying that this minus this has to be negative. And if that's the case, which one has more heart attacks? In order to get a negative result, which one has to have more heart attacks? The placebo has more heart attacks. That's the only way to get a negative result. Because if those on aspirin had a heart attack more, there would be a positive result. Exactly. So, yes. So can we conclude that aspirin will reduce the number of heart attacks? Yes. Since the confidence interval is negative. Or only negative.
That's the answer?
Mm-hmm.
Oh, okay.
Any questions there? Yeah.
Just so you know, I accidentally ripped the door handle off the door.
I'm sorry. I'm sorry,
I
Kyle,
can't
what?
lock it later.
Does the door open at all?
I mean, I don't know.
Are we checking?
I'd actually prefer that it just doesn't open and we'll just use the other door.
You can lock it.
You can lock it?
You just hulked that door.
That is hilarious. Yeah, don't stress about it. It's fine. I'll call facilities. I'll let them know. Oh, it's too funny.
I just bent this metal with my bare
Any questions, guys?
Just to rather use my hand.
Oh my god. All right, guys, I think we have time for one more. Let's do one more. A study asked participants to describe their level of concern that their pet would need vet care in the near future. Of 502 women, 104 responded they were concerned that their pet would need vet care in the near future. Of 496 men, 85 responded that they were concerned their pet would need vet care in the near future. Construct a 95% confidence interval to estimate the difference between the proportion of women and the proportion of men who are worried their pet would need vet care soon. Round all parts to 3 decimal places. So, similar to before, we're working with 2 populations, the men and then the women, or women and men, because they just listed the women's information first. So let's just go in the same order. Find the sample proportions and the sample difference. So for the women, the sample proportion, I'm going to call that my P1 hat. For the women, we were told 104 out of the 502 were worried their pet would need vet care soon. All right, that was right here. Of the 502 women, 104 responded. I'll highlight that. And that is 0.207. Similarly, then, for the men, that'll be P sub 2 hat. For the men, where is it? Right here. We were told 85 responded that the men were concerned out of 496. So 85 out of 496. And that will give you 0.171. And then remind me, we need to find the sample difference. What is that asking us to do? Subtract those values. Good. So P1 hat minus P2 hat. 0.207 minus 0.171. That'll be 0.036. Part B, find the estimated standard error, which is on your formula sheet. The first formula sheet under Unit 7, confidence intervals, you can see the estimated standard error is P1 hat times 1 minus P1 hat all over n sub 1 plus P2 hat times 1 minus P2 hat all over n sub 2. And we have all the information needed, so substitute in. So this is the square root of, okay, so P1 hat is first, that'll be 0.207 times 1 minus 0.207 all over n sub 1. So that's the sample size of the women, which was 502. Plus, then we do it for the men. So P sub 2, that'll be 0.171 times 1 minus 0.171 all over n sub 2, the sample size for the men, which was 496. Calculator, calculator, calculator. Taking your time plugging that in. Rounding to 3 decimals is 0.025. Part C, find the margin of error. Again, that formula is on the formula sheet, which is E equals Z sub C times the estimated standard error. Which remind me, where do we find the Z sub C?
On the sheet.
On that sheet, right? Your formula sheet, on the table, right? So you have to identify the confidence level. We were told the confidence level is 95, right? 95%. And then look into that sheet, the confidence level 95%, we're told that the Z sub C is 1.960. So 1.960 times the estimated standard error, which we just found, the 0.025. That'll give you 0.049.
I just got point four.
Did I do it wrong? Let's see.
No, I got 0.0.
Okay.
No, it's at 95. So 1.970.
That's what I did.
Oh.
You do 0.025?
Oh, I did point two
Oh,
five. Okay, thanks.
Part D. Write the 95% confidence interval in interval notation. All right, so, and again, that's on the formula sheet. In case you forgot, it's P1 hat minus P2 hat minus E, comma, P1 hat minus P2 hat plus E, where we already found the P1 hat minus P2 hat. We did that here. We had gotten that to be the 0.036, so that part is just being brought down. So we have 0.036 minus E and then plus E. So we minus the 0.049, comma, 0.036 plus 0.049. Simplifying each of those results in negative 0.013, comma, 0.085. Lastly, explain the confidence interval in the context of the problem. We are 95% confident that the difference between the proportion of women and men who are worried their pet would need vet care soon is between, and then convert those values to percentages, negative 1.3% and 8.5%. Yeah.
So how come on the previous one, we had like an extra step, like,
It
you
just,
know what I mean?
yeah, I just did. All right. So, when we continue in the optional out-of-class review session, we'll pick up with the single population mean hypothesis test. I'm going to stop the recording.